Hello and welcome to the finale of the IB Chemistry May 2025 Paper 2 HL freaking walkthrough. If you're looking for the SL equivalent questions, as I said at the beginning of every single freaking video, look at it here. Okay, cool. So this video is going to be covering the last bit, so question 3c, the HL only subparts, as well as question 4 AV. I think it's the one awkward HL only question in question 4. So, this question has to do with mass spec, which makes you all go, I'd have a panic attack, but don't have a panic attack. And it's a mass spectrum of phosgene. And so before we even look at this question, we should remember what the heck phosgene is. That is COCl2, or this carbonyl with 2 kind of chlorines on it. Okay, carbonyl dichloride, I think is also what it was called. Can I think focus? Yeah, cool. And so the first question is to outline why there are peaks at MZ values less than that of the molecular ion. We should remember where the molecular ion is. It is roughly around here because it is representing the molecular mass, which is roughly 97.91. Okay. And so essentially kind of why there are peaks at that less than that is because the ion then fragments. Okay. So it is fragmentation. A very simple answer there. And actually this question is kind of spoiled because in this part 2, it says deduce the formula of the fragment. It kind of gives you the answer. Anyways, so moving on to that part is to deduce the formula of the fragment that occurs at MZ is equal to 63. Okay, and so to answer this question is there's the easy part and then there's the hard part, which does require a little bit of explaining. Okay, and so whenever you deduce the formula of the fragment that occurs at MZ 63 is okay. The stuff that shows up in the mass spectra, they're all of these represent cations. Okay, because the mass spec only detects charged species. Okay, like the first step of the mass spectra kind of process is ionization. Like you vaporize it, you ionize it, you like spin it in circles, and then you detect crap. Okay, and so these are all cations. But whenever like the formation of those cations comes from essentially, like you put this bad boy is a bunch of electrons shot at it, right? And so whenever that happens, it essentially forms this weird, we say the molecular ion, but it's an ion and essentially a radical. Okay, where that radical and that positive charge is, question mark. Okay, but eventually it essentially breaks down into the various fragments, and whichever fragment there is you have whatever shows up as the peak. So in this case, spoiler alert, is it's going to be the COCl plus, and then you also have the radical that is formed, Cl blank, and that isn't detected by the mass spectra guy because it's not a charge, it's a neutral radical, but it's showing that is what is lost. You don't detect what is lost, but you can calculate what is lost. Okay, and so like the way that I came up with the COCl, the easy part, is by going, okay, that 97.91 is overall what we have. So 97.91. Meanwhile, we have still being detected as our cation 63. And so what is left over, our neutral radical, has a mass of 34.91, which is pretty dang close to chlorine, which I believe is 35.45, if I'm not mistaken. I could be a little bit off. I don't really have chlorine. I might have chlorine memorized. I don't know if I have it memorized correctly, but it's somewhere around that 35. Okay. And so that is saying that chlorine radical is what is lost. But since we're talking about 63, that is that COCl. And we can verify that by going, okay, 12.01 plus 16 plus 35.45, which is 33.46, which is roughly 63. And so that matches the mass of our fragment. So you have to put COCl, which I feel like is the easy part. However, you also have to put that it is a cation. Okay. And so I say this, I explain this because I feel like some people may mistakenly put a radical, which one just isn't what the mass spectra detects. The mass spectra only detects charged species. And two, I feel like this misconception may come from the fact that the data booklet says possible neutral fragments lost, because the data booklet doesn't tell you like these peaks. This isn't what it's detecting. It's not detecting a CH3. It's not detecting an OH. Is it detects what is left over once that part breaks off, which is the cation. Okay, and I feel like that's kind of a common misconception that students have. So it has to be COCl and it has to be a cation. It says that directly in the mark scheme. You have to have the plus charge to get the mark for this one. Okay. Meanwhile, this part 3, it says to predict the main features of the IR and H NMR spectra of phosgene and to use section 20 of the data booklet. So for the IR, that is, we're going to look for the CO bond, because that is our big bond that we're going to have. That is very stereotypical. You can look at this data booklet, which is in here, which is that CO is going to be a strong peak from 1700 to 1750. I'm going to be honest, I have that memorized. So we're going to go just from, because it's a big characteristic peak. So we're just going to put strong CO peak from 1700 1750. Is it centimeters cubed? Centimeters negative third. Negative first. Oops. My bad. Okay, and so that's going to be there. Now for the NMR, you may be tempted. What you may be tempted to do is go into your funny little data booklet and go, oh, I'm going to look for something that I have, something, maybe that there's an X, there's like a halogen. Oh, there's a halogen. Dog, the formula of phosgene, COCl2. This is H NMR. There are no hydrogens in this molecule. Will not show up. This has no hydrogens at all. Fair question. I know, I was happy and I spotted that during this exam. Okay, now finally, this awkward question 4, AB. So it says this strychnine, I think is how you say it, structure contains chiral carbon atoms, and to outline what is meant by this term. So this is, once again, I feel like this exam compared to older exams has a lot more definition defining than usual. But anyways, so chiral carbon literally just means a carbon that is connected, that has 4 different groups. That is it. Once again, this exam maker was on crack whenever he was making this, because they put way too many lines for the majority of these questions. But yeah, so that is that one. So that is the end of the HL version of paper 2 and the end of this entire godforsaken series. Yay! If you made it this far, good job. My voice hurts. This is like 6 hours of footage, I think. Good luck on your future exams, whether this is in 2025, 2026. I don't know how long this will stay on YouTube. I don't know if anyone will ever watch it. Who knows? But good luck if you happen to be watching this. I believe in you. You got this.